Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. So if I ask you whether 27013,957, look at the number given here, it's a big 8-digit number. Is it divisible by 41? So what are you going to do? I think most of us will try to divide this number by 41 and then check whether it is fully divisible or not. But wait, we have lots of smart things which we are still to learn, and in this video I am going to take up the divisibility rules of all the numbers up to 100. And when I say all numbers up to 100, I do mean it. Just watch this 20 minutes video and you will learn all the rules. Rather, the more interesting fact is you will be making your own divisibility rules, and that too, for each number you will have two divisibility rules. So many good things coming up in this video. So if you have not subscribed the channel till now, click the subscribe button and click the bell shaped icon for getting all the notifications so that you don't miss out on any fun which we are uploading daily on the channel. So what are the divisibility rules which are taught at school level? You must be knowing the divisibility rules of 2, 4, 8. And then the divisibility rules of 5, that's pretty easy. And then we have the divisibility rules of 3 and 9, they go together. And 2, so 2, 3, 4, 5. Divisibility rule of 6, we all know that. 7 is never taught in school. 8, 9, 5 and 10, yes, both together. And then I think divisibility rule of 11. Now these are the numbers whose divisibility rule you find in the textbooks at school level, and most of the students, even teachers, they know the divisibility rules of only these numbers. So very quickly let's just revise these divisibility rules, and then I will come to the important ones. What about the numbers which are apart from these numbers? Big numbers like 41. Can we check whether a big number is divisible by 41 or not? Or for that matter, maybe 71 or 73, the divisor? We can do that, and that too very easily. Watch. The first thing is the divisibility rule of 2. So we just need to check the unit digit, right? If the unit digit is 0 or even, then the number is divisible by 2. For 4, the last 2 digits of the number, this number. So suppose whatever is the number followed by 12. So yes, 12 is divisible by 4. So the entire number is going to be divisible by 4. Likewise for 8, we have the rule that the number formed by the last 3 digits, just like suppose you have any number of digits here followed by 108. See, 108 is divisible by 4, right? So it is divisible by 4, divisible by 2, but is it divisible by 8? 8 ones are 8, 28, no. So this complete number will not be divisible by 8. So if I take some other example where the last 3 digits are divisible by 8, suppose you have a number like 1, 2, 3 and then 808. Now see the last 3 digits, 808 obviously is divisible by 8. So the entire number 1, 2, 3, 808 is divisible by 8. So 2, 4 and 8, they go hand in hand. Likewise 5 and 10, that's most obvious. For 10, the last digit has to be 0. For 5, the last digit has to be either 5 or 0, right? That is the most obvious rules. Now 3 and 9, they are studied together because they are based on the digit sum of a number. So if the sum of the digits of a number, just like 7, 1, 1, 3, 6, if I add all these numbers, 7 plus 1 plus 1 is 9 plus 3, 12 plus 6, 18. So 18 is divisible by 3, and therefore this complete number is also divisible by 3. And 18 is divisible by 9 also. And so this is divisible by 9 also, right? I think you know all these rules. Then 6, because the factors are 2 into 3, and therefore if a number is divisible by 2 and by 3, then it is divisible by 6 also. It has to be divisible by both 2 and 3. For 11, we have the even odd method. If you remember, even odd method is like, suppose you have 7, 1, 4, 3, 8, 6, 5, and I want to check whether this number is divisible by 11. So I'll take the even positions. 7 plus 4, 11 plus 8, 19 plus 5, 24, and subtract what? The even positions. 1 plus 3, 4 plus 6, 10. Now you get 14. 14 is not divisible by 11, and therefore the entire number is not divisible by 11. So this is just a gist of what you do at school level, and I think most of us know that, right? Now come to the important part. Why have we missed out the number 7 from this list? 2, 3, 4, 5, 6, 8, 9, 10, 11. Why not 7? And there's a reason why 7 is not given at school level. I think only 1 out of 100 students think, and even teachers don't know the rule of divisibility by 7. So let's see what is that particular concept which is going to help us in cracking the divisibility rules of any number up to 100. I will be taking prime numbers because that is most difficult, and if it is an even number, like suppose I have to check divisibility by 12 or divisibility by some number like 14. So 14 can be broken down as 2 into 7, right? So if a number is divisible by 2 and by 7 both, then it is divisible by 14 also. And that is why the divisibility rules of even numbers are not to be studied. We will be studying odd numbers which are prime, right? So we will start with 7. So for that, I just need to tell you a basic concept first. See, 7. I want to convert this 7 as something ending in 1 or something ending in 9. Okay. Now, if I multiply 7 by 3, I get a 21 ending in 1, and if I multiply 7 by 7, I get 49 ending in 9. So these are the two ways I can get to a number ending in 1 or ending in 9. Now if I subtract 1 from this, I get 20, a rounded number of tens here, and if I add 1 to this, I get 50, again rounded number of tens. Now this is the first step. I subtracted 1, right? So subtracted 1 means minus, and how many tens are there? 2 tens. So this minus 2 is given a special name in divisibility rules. I'll tell you later. Similarly here I added 1, so plus, and how many tens? 5 tens. So plus 5. Now these two numbers, minus 2 and plus 5, they are known as the oscullators. Oscullators for checking divisibility by 7. Because I started with 7 and therefore I found out the oscullators for 7. Now just understand how we can check whether a number is divisible by 7 or not. Now let's take an example where we have a 3-digit number maybe, or let's take a 4-digit number, 3948. 3948. Now I want to check whether this number is divisible by 7 or not. So I told you the oscullators now. See now what happens here. If I consider the oscillator minus 2, I will separate out the last digit 394, and since it is minus 2, so I will do minus 2 times this, that is 16. So what will I get? 94 minus 16. So 94 becomes 84, then 74, and then 78. So 378. I can still separate out the last digit, do 37 minus again 2 times this, 16. What will I get? I will get 21. And now this is quite easy because I know that 21 is divisible by 7, and so the entire number 3948 is divisible by 7. Likewise, I can frame another rule for the same number 3948. Now watch. The other oscillator is plus 5, right? So I will separate out the last digit 394. Now plus 5 times this is 40. So I get 394 plus 40 is 434, and then again separate out the last digit. So 43 plus 5 times the last digit 20 is 63, right? And now I know 63 is divisible by 7, so the entire number is divisible by 7. So both the oscillators, they give me two different rules through which I can check divisibility by 7. But even if 7 times table is not known and you don't know 63, you can still separate it out and convert it into a much more easier number. 6 plus 5 times 3 is 15. Now you get 21, and now 21 is 7 times 3. Pretty easy, no? Right? This is how you use the concept of oscillators. Now let's calculate the oscillators for different numbers, different prime numbers. Now for a number like 13, whose divisibility rule we don't know, let's have one oscillator which is much more easier than the other oscillator. Okay. Now if I want to multiply 13 by something and the number should end in either 1 or 9, this was the rule I told you, right? It is easier for me to get to 13 3s are 39, because 13 7 times is 91 will be a big number. 91 will be a big number, so oscillator will also be big. So I will only take the oscillator which is smaller and easier to apply. So 39, now 39 plus 1 gives me 40. So the oscillator for 13 is plus, because I have added 1 here. So plus, and how many tens are there? 4 tens. So the oscillator is plus 4. And now we can check divisibility of some numbers by 13 using the oscillator plus 4. Remember, there is one more oscillator which I have left here because I want to just tell you that there are two oscillators and use only the easier one to find the divisibility. Now let's check 7, 3, 9, 3, 1. And I want to check whether this is divisible by 13 or not. So I know that for 13 the oscillator is plus 4. So I will separate out this number 7393 and then plus 4 times the last number. So this gives me 7397. Separate out the last number 739 plus 4 times the last digit 28 gives me 9 plus 8 17, 7, 1 carry means 6 and then a 7. So separate out the last digit again. I'll keep on doing that till I feel comfortable with the number which I obtain. So 4 times 7 is again 28. So how much is this? 90, 104. Now if I know that 13 8 times is 104, I will stop here. But even if you don't know that, just separate out one more time and do it once more. 10 plus 4 times 4 is 16. You get what? 26. And obviously 26 is divisible by 13, thereby proving that the entire number 73931 is divisible by 13. Right? Does it work? If you have understood like 70% of this now, this will work and you will start making your own divisibility rules for different numbers. Let's try for 17. 17, if I want to end a multiple of 17 with 1 or by 9, which one is easier? 17 3 times is 51 and minus 1 gives me 50. So what is the oscillator? Since I subtracted, the oscillator is negative and 5 tenths means minus 5 is the oscillator for 17. Now we can check. Let's take an example. 156808. I want to check whether this number is divisible by 17 or not. So separate out the last digit. 15680 minus 5 times 8 is 40. So I get 15640. Separate out the last digit. What will happen? You will get 1564 only. So 1564. Separate out the last digit. 156 minus 5 times 4 is 20. So you get 136. Now if you know 17 times something 8 is 136, it's okay. If you don't know, just separate out once more. 13 minus 5 times 6, 30 is what? It is minus 17. And see, even if you get a negative number, 17 is divisible by 17, right? And that proves that the entire number 156808 is divisible by 17. Can you tell me the other oscillator for 17 in the chat, in the comment box here? Because I have taken the number ending in 1. Can you take the number ending in 9 and tell me what will be the oscillator for 17? Okay, try that. I'll review the comments. Let's move on to some big numbers now. So I have told you oscillators up to 17. How about the oscillator of 19? I will do 19 times 1. So for 19 it will be 19 and then plus 1 gives me 20. So the oscillator will be plus 2. This is the oscillator for 19. How about the next prime? 21, 23. For 23 I will do 3 times 69. Plus 1 gives me 70. So oscillator is plus 7. That's the oscillator for 23. The oscillator for the next prime 25, 27, 29. 29 1 times is 29 and plus 1 gives me 30 and therefore plus 3 is the oscillator for 29. Now you can keep on framing your own rules. Let's have 31, very easy. 31 times 1 is 31. Subtract 1, you get 30. Oscillator is negative 3. See? Which number, which prime number is there for which you cannot frame the oscillator and you cannot frame the divisibility rule? I don't think that number exists. You can frame a divisibility rule for anything. Let's do 37. What will be the oscillator for 37? I will do 3 times because I will get a 1 at the end, right? 90 plus 21, 1, 1, 1. So subtract 1, you get 110. So negative oscillator and 11 tenths. So negative 11 is the oscillator for 37. 39 is not prime. 41, very easy again because it is 1 times, is 41 minus 1 is 40. So negative oscillator with the 4 tenths, so minus 4. See, the oscillator differs for every number. Every prime number has a different oscillator. We can do 43. 43 times 3 is 129. Add 1, you get 130 round figure. We added 1, so 13 tenths, so plus 13 is the oscillator for 43. You want one more? Let's take 47, which is prime. 47 times 3, 120 plus 21, 141. Subtract 1, you get 140. Since we subtracted and 14 tenths are obtained, minus 14 is the oscillator for 47. Keep on making these oscillators, enjoy, and I think you will frame 2 divisibility rules because if I am trying to get to the nearest multiple. See, 1 ending in 1, but it can end with 9 also. So you will have one more oscillator. For every number, every prime number, you will have 2 oscillators and 2 divisibility rules. That's why I told you in the beginning of the video that you will be able to frame your own rules, that to 2 different rules for every prime number. Let's check some questions now. I want to check whether 1, 5, 9, 8, 8 is divisible by 23 or not. So when I did oscillator concept, the oscillator for 23 is 23 3 times 69, so plus 1, so 70. So plus 7 is the oscillator for 23. And if I know this oscillator, I will separate this out. 1, 5, 9, 8 plus 7 8s are 56. This will give me 14, 4, 1 carry means 15, 5, 1 carry means 6 and 1. So separate it out. 165 plus 7 4s are 28. So this will give me 93. 193. Separate out once more. 19 plus 7 3s are 21. 40. 40 is not divisible by 23. So this number is no, it is not divisible by 23. So we can go on and do some more questions. And finally, I'll take the one which I gave you in the first slide. On the first slide, I gave you a number and I asked you whether you can find that or not. Let's take a number like we can have divisibility by 59. Can we check 59? Let's take a multiple of 59 so that we are sure that the number which we are taking up is actually divisible. So 20886. Now I want to check whether this is divisible by 59 or not. So the oscillator for 59, how do you calculate? 59, 1 times is 59, add 1 you get 60. So plus 6 is the oscillator. So let's separate it out. 2088 plus 6 times 6, 36 is 14, 4, 1 carry means 12, 2, 1 carry and then 2, right? Separate out the last digit, 212 plus 6 times 6 fours are 24. So this is 236. Separate out once more, 23 plus 6 times 6, 36, and so we have what number? 59, and there we go, the number 59 itself was the divisor, and so the entire number is divisible by 59. And finally we have the last question which I gave you in the beginning of the video, and that was 2701395 divisible by 41 or not. So let's do this question now. So the oscillator for 41 was minus 4. The oscillator was minus 4. Let's try. Separate out 2701395 minus 4 times. So that is 28. So you should be really quick in adding and subtracting numbers. So 95 minus 28. 67? Yes. So 67. Separate out. 270136 minus 4 times 7, 28 again. So we have 2701 and 36 minus 28 is 8. So 08. Separate out 27010 minus 32. So what will this be? Now 27010 and 32 is to be subtracted. So 8 and then 7 and then you have 9 here and then 6 and 2. So 26978, and finally separate out 2697 minus 4 times 8 is 32. That gives you 2665. It's getting closer now. So 266 minus 4 times 5 is 20, which gives us 246. And now you can check this exactly 6 times is 246, and even if you don't know that, you can separate it out once more and do 24 minus 4 times 6, 24, which gives you a 0, and 0 is divisible by all numbers, right? So we get a number which is divisible by this divisor, and so the entire number is divisible by 41. So friends, is there a divisibility rule which you don't know? I think before watching this video you knew the divisibility rules only up to 11 except 7, right? 7 also many of the students don't know. Now you know the divisibility rules of all numbers up to 100. So friends, if you like this video, do share it with all your friends so that they can also enjoy and have fun with these numbers and frame their own divisibility rules. Do share and don't forget to subscribe the channel and click the bell shaped icon for getting the notifications. Thanks for watching this and have fun with these divisibility rules. All the best.